Hi there, my name is Juliana. I am a PhD student in sociology doing studies in distributed autonomous systems. Today's topic is about human machine systems, which is a major area of my approach to doing research because I'm speaking of distributed human machine cognition. So, human machine systems are this kind of like larger scope of social technical understanding, right? The conceptual approach to human machine systems is pretty much the coupling of humans and machine elements as a larger apparatus, so a hybrid system composed of humans and machines. So when you use your computer, the link between yourself and the computer establishes an extended system that is a human machine system, or you can have, collectives of humans and machines. So, for example, Google or Microsoft or Apple, these are very large social technical systems, so very large human machine systems where you have a lot of technological and human elements operating in parallel in this system simultaneously and networked and all of that good stuff. So essentially the concept is this coupling of humans and machines, right? So there's a lot of the research is moving very fast in this area. You see a lot of human computer interaction research in the market. So Microsoft, Google, Apple, they study a lot of human machine cognitive interaction to develop their services and products. So, this is one area of research that's a bit more particularly focused on industrial application, so commercial application, and developing consumer products and the technologies that we use in our everyday lives. This will lead to a lot of developments in user interfaces, so brain machine, which are essentially brain machine interfaces, a lot of times at least. When you have a computer, when you're in front of the computer, your brain is connected to that system in certain ways, and I'll explain that in a second. But let me first give the second trending research area that I wanted to talk about here, and that is human swarm partnerships. This is a bit more within the academic environment. This area is really booming right now. And I mean, it's good in a sense, but then somehow it's a bit concerning because a lot of what is pushing this research forward is a lot more connected to military developments, military funding, and yeah, defense systems, particularly in this human swarm partnerships, but not exclusively, right? They also use these systems to address, for example, let's see, like recovery of tragic situations, like forest fires or floods and things like this. There's a lot of research being done in that area so that you can take, swarms of drones into certain areas where are very difficult to reach. Disasters, I said tragic situations, like I meant to say disasters. So human swarm partnerships is very large in the academic research right now, in the scientific environment. And within the market, you see a lot of human machine cognitive interaction, human machine interactive, human computer interaction within the industry, right? So essentially, when you're coupling humans and machines through these brain machine interfaces, you have to identify, when you're doing research in that area, you have to identify how information flows through the system. And when I say through the system, it's through the hybrid system, how information flows from the machine element to the human element in the system, and how that goes back and forth and establishes a feedback loop in the human machine system. To understand that, you have to dive very deep into the cognitive sciences, cognitive neuroscience particularly. So I'm going to explain very briefly how the information flows from between humans and machines in this coupled system here. So you have what is happening at the technological system, right? So you have the computer, the computing device, right? It's a technological device. You have a network that runs in the background of that device. Even when you're looking at your computer, you have the motherboard. The motherboard has a lot of networks within that board, but then it extends larger into, the world, like large scale network, which is the internet. So electrical signals are running through those networks, right? And these electrical signals, they are then transduced into the information that we capture at the level of the interface. How is this signal transduced? Well, you have electrical signaling. That is what 0101 is. 01 means light or no light. Well, the opposite, right? No light, light. 0 is no light, 1 is light. And then the fiber cables or the cables in that network, the links, they will just kind of fire, very quickly. This all happens very quickly, right? But it will fire the electrical signals in that sense. What the computer does then, it translates that information, it transduces that information into the programming language that is a bit more accessible for us to understand than the 01s, because 01s are such massive strings of numbers. So then those are compiled in blocks and then translated into, words of a programming language or signs of a programming language. And those create the software within the interface that will then project the information that you're going to perceive through your sensory systems in semantic forms of representation or visual stimuli that your brain can actually understand, right? So that interface and that technological system means that is a form of technical cognition going on. Then that information gets transferred to the human agent, right? The human cognizer. That information is transferred through also like energy frequencies, right? Because your visual system is observing energy frequencies into your visual system, into your sensory system, essentially. And that energy, those streams of energy frequency are going to travel through your neurological networks, with the neurological networks within your brain, in the form of neurological signaling. And this gets very complex in the way that information travels through the brain. But essentially, particular signs, particular shapes, they get, they get identified, they get recognized by your memory systems, or it will be absorbed as new memory formation, right? And patterns are then identified and recognized, and that's how knowledge takes place, or recognition of things in the environment. This is a bit, maybe a bit of a like there is a deeper and more detailed explanation, but this is pretty much like as good as I can explain in a bit of more objective way for you to understand how information flows from the technological system so the technological networks within the computer and the larger network that connects all of the other computers and people to the networks within the brain. This is all happening very, very fast, right? So the electrical signaling flows through the technological system and then is transduced by the computing device transferred to the human agent in the form of energy frequencies that are captured by the human's biological sensory systems. The energy frequencies travel through specific neurological networks and accesses memory recognition. Now, one last observation is that human machines, somehow the computing industry made it seem like cybernetics was just a technological systems, just a technological environment, or the technological functioning in machines. But essentially, if you go back to cybernetics, to the origin of cybernetics, you will realize that cybernetics was never meant to be without humans in the loop in the first place. You can find this very clearly in one of Norbert Wiener's talk that he gave in 1954 at the New York Academy of Medicine and Science. The article is called Men, Machines, and the World About. And there's a part here that he's explaining how he got into cybernetics and how he actually worked his ideas in cybernetics and came up with the concept of cybernetics and so on. But he does say, well, the actual, he says, he's explaining the machine that he was trying to work with, and he will explain this. This is within military research. So he says the gun pointer is a human element. This human element is joined with the mechanical elements. The actual fire control is a system involving human beings and machines at the same time. It must be reduced from an engineering point of view to a single structure, which means either a human interpretation of the machine or a mechanical interpretation of the operator, or both. So he's really gives us this notion of cybernetics as a human machine system. So this is it for today. The article I mentioned is called Men, Machines, and the World About. It was actually a talk delivered by Norbert Wiener. He is the father of cybernetics. He gave this talk in 1954. Highly recommend his work for us to understand cybernetics from a very original, conceptual, and scientific proposal. His work is, one of the first ones. The entire cybernetics field really just sprawled from his ideas. He's a mathematician and philosopher, highly considered the father of cybernetics. That's it for today. Thank you for listening, and until next time.